I'm Dr. K.Anitha. Welcome to part 3 tutorial of discrete mathematics. Today, let me discuss about generating function. Generating function is a way of encoding an infinite sequences of numbers by treating them as the coefficient of power series. The general form of generating function is given by g of x equals summation of n equals 0 to infinity a n x power n. It is a continuous function associated with given sequence. For this reason, generating functions are very useful in analyzing discrete problems involving sequences of numbers or sequences of functions. The main application of generating functions are it is used to solve recurrence relations. These are the step-by-step procedure for solving recurrence relations by using generating function. Step 1. In step 1, rewrite the given recurrence relation as an equation with the 0 on right hand side. Step 2. Multiply the entire equation by x power n and summing it from 1 to infinity, 2 to infinity, etc., which is based on the equation which we have. Step 3. Put g of x equals summation of n equals 0 to infinity a n x power n. Step 4. Decompose g of x into partial fraction. Step 5. Express g of x as sum of familiar series. Express a n. Step 6. Express a n as coefficient of x power n in g of x. These are the standard results used to solve recurrence relation. G of x equals n 0 to infinity a n x power n or 1 to infinity a n minus 1 x power n minus 1, 2 to infinity a n minus 2 x power n minus 2. Summation of n ranges from 1 to infinity x power n equals x into 1 minus x whole power minus 1. So n ranges from 1 to infinity a n x power n is g of x minus a0, and n equals 2 to infinity a n x power n is g of x minus a0 minus a1 x. So 1 minus ax plus ax the whole square minus ax the whole cube can be written as summation n ranges from 0 to infinity minus 1 power n a power n x power n, whereas in all the terms are all the arithmetic operators are positive plus symbol. Summation equals summation n equals 0 to infinity a n x power n. This is the first example problem. Solve the recurrence relation. Here the boundary conditions are a0 equals 10 and a1 equals 41. So I'm going to solve this problem. Solution. Multiply the entire equation by x power n and summing it from n equals 2 to infinity, because we are given that n starts from 2. Multiply by x power n and n starts from 2 to infinity. So summation of n equals 2 to infinity x power n a n minus 7 summation of n equals 2 to infinity x power n a n minus 1 plus 10 summation of n equals 2 to infinity x power n a n minus 2 equals 0. From the above result, n equals 2 to infinity a n x power n equals g of x minus a0 minus a1 x. So we can write this expression as g of x minus a0 minus a1x. For second expression, we have to convert this into the general form, that is multiply and divided by x here. N equals 2 to infinity x power n x power minus 1 a n minus 1. Similarly, for the third expression, here we have to multiply and divided by x square. So multiplication, division, x power minus 2 represent the division. A n minus 2 equals 0. So g of x minus a naught minus a1x minus 7 times of x summation n equals 2 to infinity a n minus 1 x power n minus 1 plus 10 times of x square summation n equals 2 to infinity a n minus 2 x power n minus 2 equals 0. From the above standard results, we can write n equals 1 to infinity a n minus 1 x power n minus 1 as g of x. Here we are having n equals 2 to infinity a n minus 1 x power n minus 1, which can be written as first expression same e naught e1x minus 7 times of x. We can write this expression as g of x minus a naught. Similarly, 10x square g of x. Here we are given that a naught equals 10, a1 equals 41. Substitute these values in the above expression. G of x minus 10 minus 41x 7x g of x plus 70x plus 10x square g of x equals 0. From the above expression, g of x 1 minus 7x plus g of x, here minus 7x, here 10x square. 10x square equals 10 minus main to 29x. Maintain g of x term as left hand side, other terms as right hand side. So g of x equals 10 minus 29x divided by 1 minus 7x plus 10x square. So we can factorize this expression. Before that, g of x equals 10 minus 29x divided by minus 10x square wait we can factorize this one. That is 10x square minus 7x plus 1. 10x square minus 5x minus 2x plus 1. Here 5x is common, so 2x minus 1, and here minus 1, 2x minus 1, so 5x minus 1, 2x minus 1 are the required factors. So 5x minus 1, 2x minus 1. Again we can write 10 minus 29x. For making the familiar series, we can write 1 minus 2x, 1 minus 5x. Next step, decompose the above expression by using partial fraction. 1 minus 2x, 1 minus 5x equals a by 1 minus 2x plus b by 1 minus 5x. Solving this above expression, we got the value of a equals 3, b equals 7. So hence g of x equals 3 by 1 minus 2x plus 7 by 1 minus 5x. G of x equals 3 into, when 1 minus 2x goes to numerator, it will become 1 minus 2x whole power minus 1. Similarly, 1 minus 5x whole power minus 1 equals 3 into summation of n equals 0 to infinity 2 power n x power n. So this step is derived from this results. Here also 7 summation of n equals 0 to infinity 5 power n x power n. So an, the solution is coefficient of x power n from the above equation. Hence an equals 3 times of 2 power n plus 7 into 5 power n, which is the required solution for the given recurrence relation. We can solve many problems by using the above procedure. Thank you for watching this video.